I'm Andrew, and this is my Mechatronics 5275 class project. What we have here is a motorized bicycle, and on the back is all the electronics. We have a 12-volt DC power supply that's plugged into the wall, and that is being stepped down to 6 volts with this regulator to power a servo. The servo actuates the gear shift lever on the bicycle. And here we also have a Arduino Mega, and the Arduino Mega is running a Simulink model that lets it send commands or send output signals to turn on or do a pulse width modulation on this transistor here, which is a MOSFET, and so that MOSFET is in series with the DC gear motor down there. The DC gear motor has a encoder which measures or can be used to measure the speed of that motor. That's being monitored by the Arduino, and you also have another MOSFET here to basically enable the servo. That's there so that we can make sure that the servo is not getting power until a servo command is ready to be sent to it. So I make sure the servo doesn't move unexpectedly and break something that we don't want it to. Okay, so that explains the electronics. On this other side, we have some of the mechanical system. That DC gear motor is attached to the sprocket. That sprocket is driving the smaller of the 2 chain rings on the crank, and the rest of the bicycle is just standard bicycle. So when this gear shift lever is actuated, it will shift the gears on the back wheel. So on my computer right now, I have pulled up the Simulink model that's implemented on the Arduino. This uses serial communication to talk between the Matlab script and the Arduino. So here's the serial input block for the Arduino, and I have these interval tests set up to basically route the incoming data to specific functions. So depending on the value of the input, different ranges mean different things. Such as speed set point, enabling the servo, a gear shift signal, and system enable and reset. So that's we also have a discrete PID controller here. I don't really use this PID controller in this test that I'm going to do. Basically what I'm going to do is ask for a set point speed that's more than what the motor can actually do. So it's going to saturate the controller and just give me a constant 12-volt output, a 12-volt supply to the motor. Then this Simulink model has some Arduino output blocks. Here's a digital output that's used to enable the servo, PWM output for the DC gear motor speed, and a servo write block that sends 1 to 2 millisecond pulses to the servo. And inside this gear shifter block, I just have different angles preset that I calibrated, and those correspond to the angles the servo needs to move to shift to different gears. So this model is already uploaded to the Arduino. We can go to Matlab, and here I have a Matlab script that is going to create a graphical user interface and let us interact with the system. So I'm going to run that. We've established communication with the Arduino. So now here we have the graphical user interface. I'll make it a little bigger. And what we have here is we can set the motor speed that we want. So I'm going to set that to 250 RPM. It really only can go up to about 120. And our runtime is going to be 20 seconds. Okay, here we're going to run a test where we start from first gear and use the shift button in the GUI to shift up when the motor kind of spins up. And then we can see the speed response on the plot as it's running. So I have the servo enabled, and we're going to start. Okay. So on the screen we can see every shift that occurs. There's some delay between when I press the shift button and when it actually shifts, so it's calculating the wheel speed and plotting it as this green line, and so that's why we see the jump in the wheel speed when I give a shift command, because it's using the it assumes that it's in that gear already once, immediately when you press that button. But we see it's actually taking a little time. So that red dots are the motor speed that's measured using the encoder that's on the motor. And then down here on the blue we have the motor, or the total distance traveled by the wheel. So now we can restart the control, and I'm going to change the distance line to red, and here we're going to start in the highest gear, 5th gear, and disable the servo and just run it starting from rest in 5th gear. Here we go. So a couple things we can notice: when I had the screen full size like this, I was getting fewer data points per second, and I think that has to do with the update rate of the graphics window, kind of slowing things down when it's very large. So shrinking the graphics window allowed me to collect more data points. So now we can see this lower green line is the one from the test we just ran. You can see how the wheel speed is slower to respond in the beginning when we're starting in a higher gear. And down here in the distance graph, this red line shows the distance from the test we just ran, and we can see that the time to travel 100 meters with the starting in low gear was about 17 seconds, and starting in higher gear took maybe 17.5 seconds. So we can see from starting in a lower gear, we're able to go a little bit faster from the beginning, and that would be enough to, say, win a 100-meter race by half a second, and that's all it takes to win. So that's my project, and thanks for watching.